Welcome to this week's machine learning live reading session. For this one, we're going to talk about this article or case study put together by Chip Huyen about large language model in production. Basically, machine learning ops, MLOps for large language models. So Chip Huyen is a Stanford grad and a co-founder of claypot.ai, which is a platform focusing on building real-time machine learning systems. So as we know, machine learning model is just a very small part of the machine learning system. There's actually a lot of technical challenges in productionizing a machine learning model. So that is what is called MLOps. So let's get started. A question that I've been asked a lot recently is how large language models will change machine learning workflow. After working with several companies who are working with LLM applications and personally going down a rabbit hole building my applications, I realized two things. One, it's easy to make something cool with large language models, but very hard to make something production ready. LLM limitations are exacerbated by a lack of engineering rigor in prompt engineering, partially due to the ambiguity nature of natural language and partially due to the nascent nature of the field. So this pose consists of three parts: key challenge of productionizing large language model, how to compose multiple tasks with control flow, and some of the promising use cases building on top of large language model. So let's go to part one, challenges of productionizing prompt engineering. The ambiguity of natural languages. For most of the history of computers, engineers have been writing instructions in programming language. Programming languages are mostly exact. Ambiguity causes frustration and even passionate hatred in developers. For example, the dynamic typing in Python or JavaScript. I think many people can relate. In prompt engineering, instructions are written in natural language, which are a lot more flexible than programming languages. This can make for a great user experience, but can lead to a pretty bad developer experience. I can definitely confirm with that. The flexibility comes from two directions: how users define instructions and how LLM respond to these instructions. First, the flexibility in user-defined prompts leads to silent failures. If someone accidentally makes some changes in code, like adding a random character or removing a line, it will likely throw an error. However, in the case of prompt engineering, it will still run, and you will not be able to notice. So, while the flexibility in user-defined prompts is just an annoyance, the ambiguity in large language models' generated response can be a deal breaker. It leads to two problems: ambiguity of output format. So downstream application might expect a certain format, but it will not usually give that format. For example, if you want to have a score, like for example an essay score, or it could also be like a recommendation systems, a ranking score. Sometimes it doesn't even give you the exact score. Sometimes it gives you a score and a bunch of explanation. My personal experience is it can be eliminated by setting how much token you want it to return. So I think this is fixable. The other one is inconsistency in user experience. When using an application, user expects certain consistency of the output. So imagine an insurance company giving you a different quote every time you check on their website. That would be super annoying. You can force an LLM to give the same response by setting the temperature to 0, which is true. Yeah, that's usually how people do it. Which is in general good practice. However, while it mostly solves the consistent problem, it doesn't inspire trust in the system. Imagine a teacher who gives you a consistent score only if the teacher sits in the particular room. I don't quite understand what this metaphor means. I feel like it may mean that if you want certain variety in some results but not in the other, then it kind of is limiting. I think that's what it means. For example, I want some variety in the text output, but I don't want variety in the score or something. that's hard to do. I think that's what it means. So how to solve this ambiguity problem? This seems to be a problem that OpenAI is actively trying to mitigate. They have a notebook with tips on how to increase the model's reliability. A couple people who have worked with large language models for years mentioned that they just accept this ambiguity and build their workflow around that. It's a different mindset, how to develop deterministic programs, but not something impossible to get used to. That's true. This ambiguity can be mitigated by applying as much engineering rigor as possible. In the rest of the post, we'll discuss how to make prompt engineering, if not deterministic, systematic. Yeah, that's true. I think that's reasonable. So prompt evaluation. A common technique for prompt engineering is to provide in the prompt a few examples and hoping that the model can generalize from those examples. As an example, consider trying to give a text a controversy score, and it was a fun project to find correlation between a tweet's popularity and its controversialness. Here's a shortened prompt with 4 shortened examples. So given text, give it a controversial score from 0 to 10, and then okay, so here's generate the different scores. What first one is the math one, obviously there's no controversial. The second one is it's basically a Twitter announcement, nothing wrong, and the other one is everyone will have the right to own and use gun. Yeah, it's about gun control, of course it's high. Immigration should be completely banned, that controversial scores. But yeah, so it actually looks pretty good. So and then here you give some examples, and then here you basically ask, now you can, here's the text and here's the score. So this is called a few shot learning, meaning you provide some examples and then you now give your questions. So 2 questions to keep in mind. When the model tries to understand the example given a prompt, one way to evaluate is to input the same example and see if the model output the exact score. If the model doesn't do that, then it's likely because the prompt isn't clear. You might want to rewrite the prompt or break the task into smaller tasks. Yeah, that's true. I mean, usually if you add the example in the prompt already, it should be predict, right? It's almost like a data leakage if you look at the traditional machine learning sense. Whether the model overfits these few shots problems, you can evaluate model 2 separate examples. That's true. Overfits, it probably means you give it too specific, so it's not able to generalize. I think that's what it means in the context of large language model. One thing I find very useful is to ask model to give examples for which it will give a certain label. That's interesting. For example, I can ask the model to give me an example of text for which it would give a score 4, and then I input those examples in the model to see if it indeed output 4. So this is very interesting. So I remember the other day read about this this paper talks about how do you do prompt tuning, and this is one of the idea is you actually ask the model to give you an example based on your score, and then you take that prompt and then you modify it so you know what prompt the model likes to see. So that is a very innovative idea. So prompt versioning, yeah, this definitely is an important feature if you want to productionize your prompt, because treat it like your Git repo, treat it like your code. So small changes to a prompt can lead to very different results. It's essential to version them. I wouldn't be surprised if there will be tools like MLflow or weights and biases for prompting experiments. There already is. So prompt optimization, there have been many papers and blogs written on how to optimize prompt. So here is a reference by Lillian Wang that you guys can check it out. That most of the paper on prompt engineering are tricks that can be explained in a few sentences, but they're explained to you like a full article for some reason. So yeah, I agree with that. OpenAI has a great notebook that explains many tips with examples. I can post the link in the comment section for some of these links. I also post the link of this article as well. Prompt the model to explain step by step how it arrives to an answer is a technique called chain of thought, or COT. trade-off. So this can increase both latency and cost because you're adding more words, generating many outputs for the same input. So pick the final output by either the majority vote, known as the self-consistency technique, or you can ask the model to pick the best one. I see. So in OpenAI API, you can generate multiple responses for the same input by passing an argument in. Okay. Breaking one big prompt into small and smaller prompts. So it's kind of like you're having smaller prompts that generate the result, and then you add that result to your next prompt. So you kind of chain them together. So that's the other way to do it. Many tools problem is to auto-optimize your prompt, which I'm not seeing a very good one. They're quite expensive and usually just apply these tricks. Yeah, I would say so. So the next thing is cost and latency. I definitely personally experienced both of this. Especially if you want to work on some side projects that have some traffic, latency is a huge issue. So cost, the more explicit detail and examples you put into the prompt, the better the model perform, hopefully. But it will get more expensive. So OpenAI API charges for both input and output tokens depending on the task. So a simple prompt might be anything between 300 to 1,000 tokens. If you want to include more context, e.g. adding your own documents into retrieval from the internet to prompt, it can easily go up to 10K tokens. Wow. So maybe that makes this super important, or maybe there's a way to structure it so you can have one long prompt with several input. It will give you several output just with that one prompt of context, then it will probably be cheaper. So I think that would be one interesting direction. The cost with long prompt isn't in experimentation but in inference, of course. Experimentation-wise, prompt engineering is a cheap and fast way to get something up and running. For example, even if you use GPT-4 with the following setting, your experimentation cost will still be just over $300. The traditional ML cost of collecting data and training models is usually much higher and taking much longer. So this is the part I think brought up to the kind of the fundamental philosophy difference between GPT and some of the traditional deep neural network is GPT wants to get to a point where you don't have to train, so you can talk like a human, and obviously it's not as easy to do. So there's actually a part later in this article that talks about that. So let's continue to read. Prompt, so 10K token, so it's about 0.06 per 1K token, and output 20K token is about 0.12 per 1K tokens. Okay. So it charges differently, interesting. Evaluate 20 examples, experiment with 25 different versions. So here she's just trying to say, experiment what prompt works better is actually cheaper, but if you have like a large number of inference, when you decide to take that prompt into production, that's when it's expensive. The cost of LLMOps is in the inference, of course. If you use GPT-4 with 10K tokens and input and 200 tokens and output, it will be it'll be basically 60 cents per prediction. That's pretty expensive. So if you use GPT 3.5 Turbo, that's ChatGPT with 4K token for both input and output, it will be, wow, this is pretty expensive. This is a lot cheaper than GPT-4, but I can see the cost coming down. This is 0.004 per prediction. This is not bad. As a thought exercise, in 2021, DoorDash ML model made 10 billion predictions. That is insane. That's probably why for typical language-based model, maybe GPT is good, but if you want to do it at scale, you need to have your own model. If each prediction, yeah, I know it's 40 million a day, that's insane. No. By comparison, AWS personalization costs about 0.0417 per 1K prediction. Okay, so these are like pre-built models in AWS. AWS servers are usually considered, prohibitively expensive. That's true, but you're also comparing a pretty complicated language model to like a very basic binary classification model. So I don't think it's the same, but we get the sentiment. The other one is latency. So input tokens can be processed in parallel, which means that input length shouldn't affect the latency that much. However, the output is the one that significantly affects latency, because it's due to the output being generated sequentially. So for extremely short input 51 token and output 1 token, the latency for GPT 3.5, which is ChatGPT, is about 500 milliseconds. If the output token increase to over 220 tokens, the latency is over 1 second. Wow, that is not acceptable. That is bad. Here's an experiment that she ran. Each setting is run 20 times, and then all run happen within 2 minutes. So if you run the experiment again, the latency will be different, but the relationship between 3 settings should be similar. Okay. So basically, as you input the size of input token and output token, wow, this P90 latency is 1.62. That's pretty bad. It is unclear, however, whether the latency is due to the model or the networking, which I imagine would be huge due to high variance across run, or some just inefficiency engineering overhead. Okay, it's very possible the latency will be reduced in near future. I do believe so if they put enough engineering work into this. While half a second seem high for many use cases, the number is incredibly impressive given how big the model is, which is true. Yeah, it's a huge model, which, meaning to inference something, you have to go through all those weights in the pre-trained model. So the number of parameters for GPT 3.5 isn't public, but it's estimated around 150 billion, so that's a lot, right? And then here the Google's T5 is 11B, and then Facebook's Llama is about 65B. So people discuss on this thread that configuration they need to make the Llama model work, and it seems like getting the 30B model, 30 billion parameter model to work is hard enough. The most success for one seemed to be Rendler, who was able to get the 30 billion parameter model to work on a 120 GB RAM. So what this is saying is, how do you get that on a smaller server? I think that's what it means. Which takes a few seconds to just generate, wow, that's bad, to just generate 1 token. The impossibility of cost plus latency analysis on large language model. So this field is moving so fast that any cost plus latency analysis is probably going to go out of date pretty quickly. Matt Ross, this is the person that she quoted, is a senior manager at Stripe, mentioned that the estimated API cost for his use case has gone down 2 orders of magnitude over the last 6 months. Latency has significantly decreased as well. Similarly, many teams have told me that they feel like they have to do feasibility estimation and buy using pay API or build decision every week. That's true. I mean, yeah, whether or not you host your own model or you use Cohere or OpenAI. So yeah, it's a very interesting trade-off. So prompt versus tuning versus alternatives. So fine-tuning, I think here she refers to the general fine-tuning, not just like the fine-tuning like similar to BERT transformer, but here you can also fine-tune your model kind of through OpenAI API. So prompting means for every sample, explicitly tell what your model should respond. And fine-tuning means you train a model based on a pre-trained model, and you give it some sample and some labels, and so you don't have specify in your prompt, right? So you don't have to provide the context, you just give input. Okay, so here she gives example of these 2, I would say, paradigm of how to use large language model. There are 3 main factors when considering prompting versus fine-tuning: data availability and performance and cost. Yeah, because for fine-tuning a model, you still need close to 1 million rows of data to make it work well, and a lot of companies using it, they may not have that much data, or it's like a cold start problem. Or they do, but to pipe through that much data, that there is data engineering cost. So depending on the business, they might not need those, right? So that's why data ability and performance and cost, these 3 factors. If you have only a few examples, prompting is quick and easy to get started. There is a limit on how many examples you can include in prompt due to the maximum length of tokens. The number of examples that you need to fine-tune a model, of course, depending on the task. But this one you can use a lot more because you're basically training a model to adjust its weights to fit to your use case. You can expect a noticeable change in your model performance if you fine-tune on 100 samples. However, the result might not be much better than prompting. So this is a very interesting article about prompting versus fine-tuning. How many data point is a prompt worth? So this is a paper that talks about that a prompt is worth approximately 100 examples. Interesting. So variance across tests, obviously. So the general trend is that if you increase the number of examples to fine-tune your model, meaning you retrain your model, fine-tuning gives better model performance than prompting. There's no limit on how many examples you can fine-tune a model, but obviously there's a limit on if you go with a prompting approach, right, how many tokens you can fit. So the benefit of fine-tuning is twofold. You can get better performance and you can use more examples. You can reduce the cost of prediction because you have your own model. Right, I think here she's referring to the traditional machine learning model, or not traditional, but like transformer BERT. The more instructions you can bake into the code, the less instruction you have to put into prompt. So this is more like fundamentally, that's why the two are different. So say if you reduce 1K token into your prompt for each prediction, then for 1 million predictions for ChatGPT, you save $2,000. So that's quite a lot. So there's the other concept called prompt tuning that is in between prompting and fine tuning. So start with a prompt. Instead of changing this prompt, you programmatically change the embedding of this prompt. Interesting. So for prompt tuning to work, you need to be able to input prompts embedding. So it's the vector mapped to your prompt into your language model and generate tokens from these embeddings, which currently can only be done with open sourced large language model. Interesting. I see, because okay, what he or she is referring to is if you use natural language, tune is a bit harder, but if you basically abstract those into embedding of vectors, is a bit easier. But it's not available on OpenAI anyways. So it is available on Google's T5. On T5, prompt tuning appears to perform much better than prompt engineering, of course, right? Because you're basically tuning the model again, right? Okay. Fine-tuning with distillation. So distillation meaning you're having a smaller model to learn from the bigger model. So in March 2023, a group of Stanford students released a promising idea: fine-tune a small open source model on examples generated by a large language model. Right, that explains what distillation is. This technique of training a small model to imitate the behavior of a larger model is called knowledge distillation. The results behave similar to, this is GPT-3 or DaVinci 003, which is the largest GPT-3, while being a lot smaller and cheaper. So this is the other idea. I think it's not like to help improve the performance, but this is to help reduce the cost. It's saying, if I have this use case, and I'm using this OpenAI model that does pretty well, but I don't want to pay that much money, then I can basically distill that to a smaller model that I fine-tuned, and then that'll be a lot cheaper. So for fine-tuning, they use 52K instructions, that's their training data set, which they input into DaVinci 3 to obtain outputs, and then use those to fine-tune a Llama 7B, I'm assuming 7 billion parameters. So this costs under $500 to generate. The training process of fine-tuning is under $100. But I'm pretty sure this smaller model is much cheaper for inference. So the appeal of this approach is obvious. After 3 weeks, the REPL has over 2K stars. So yeah, obviously this makes sense, right? You're distilling that into a smaller model. So the other aspect is the embedding for a large language model. So embedding plus vector database. One direction that's very promising to use a large language model to generate embeddings and then build your machine learning application on top of these embeddings for search and recommender system. Yeah, this is a very classic one that, for example, that a lot of recommender systems are based on user viewing history, and the product description, right? So what you can totally do is take a product description and then generate embedding and take a user's browsing history of all, maybe that user viewed 20 product, take those embeddings, you have 20 embeddings, right, from the user browse history, and just take an average of those. That would be your user embedding. So now you have user embedding and query embedding. Now you have user embedding and item embedding, and you can just find similarity of those two. So this is a pretty good direction because you can actually reuse what's being computed. So that's actually pretty good. So especially for kind of like a co-star or like a small startup that doesn't want to build a very complex recommender system. As of April 2023, the cost of embedding using smaller model like text embedding ADA 002 is 0.0004 per 1K token. That's pretty cheap. So while this still costs more than open sourced models, this is still very affordable given that you only have to generate embedding for each item once. Yes, but for user, you do have to repeatedly generate them. With OpenAI API, it's easier to generate embedding for queries and new items in real time. That's true. But I still feel like this is more for small, medium businesses that don't want to build complex recommender system. They want to have a quick bootstrap way to do a recommender system. So to learn more about using embedding, check out this SGPT paper or analysis on performance and cost of GPT-3 embedding. Some of the numbers in the post are already outdated, but the method is great. The main cost of embedding model for real-time use case is loading this embedding into vector base for low latency retrieval. So yeah, like company like Pinecone is doing that vector based. There are also a couple more of those vector-based embedding databases that allows you to do nearness neighborhood retrieval. However, you will have this cost regardless of which embedding you use, which is correct. Yeah. So yeah, here are the companies she listed. And also you can also use Fies and Redis, some of those ones that if you want to set up by yourself. Backward and forward compatibility. Foundation models can work out of the box for many tasks without us having to retrain them. However, they do need to be retrained or fine-tuned from time to time as they go outdated. One observation with the situated QA dataset for a question grounded in different dates is that despite a language model pretrain cutoff is, say, year 2020, has access to latest information via Google search, its performance on post-2020 questions are still a lot worse, of course. This suggests that the existence of some discrepancies or conflict parametric between contextual information and model internal knowledge. Okay. This is just a very fancy way to say you can't just feed it with a prompt if it doesn't know those things. When it's fine-tuned, it does better, which aligns with the section earlier that compares fine-tuning with prompting. So in traditional software, when software gets updated, ideally it should still work with the code written in the older version. However, for prompt engineering, you're not sure. Right? For example, if they release GPT-4, GPT-3 might not work. If you expect model to you use to change at all, it's important to unit test all your prompt. Wow. So one argument I often hear is that prompt rewriting shouldn't be a problem because models should only work better. Yeah, that's my observation, but it has to be more reliable. And experiments with prompts are fast and cheap, as we discovered earlier. So while this is somewhat true, one big challenge that we see today in MLOps is there's lack of centralized knowledge of model logic, feature logic prompts. Yeah, that's true. An application might contain multiple prompts with complex logic. If the person who wrote the original prompt leaves, then it might be hard to understand. That's true. I think that's true for any ML system. If that key person left, and a lot of documentation are missing, and there's so many parts because it involves the backend team, ML infra team, the applied scientist team. So if one key person that architecting all these left, it's really hard to find things. So I definitely agree with that. Another challenge is that prompting patterns are not robust to changes. For example, many of the published prompt that I've seen it with, I want you to act XYZ. If OpenAI one day decide to print prompt like, I'm an AI assistant that I can't act like XYZ, then it's all broken. So, yep. So part 2, task composability. Applications that consist of multiple tasks. The example controversy score above consists of one single task. Give me an input and output a score. Many applications, however, are more complex. Consider the talk to data use case where we want to connect to a database and query this database in natural language. Imagine a credit card transaction table. You want to ask how many unique merchants are there in Phoenix, what are their names? The database will return 9 unique merchants in Phoenix are, and then a list of merchants. So one way to do this is to write a program that performs the following sequence of tasks. Convert language, natural language to SQL, execute SQL, convert the result back to language. So this leads to the next concept called agents, tools, and control flows. So she did a small survey among people in her network. There doesn't seem to be any consensus on the terminologies yet. The word agent is being thrown around a lot to refer to applications that can execute multiple tasks according to a given flow. A task can leverage one or more tools. In some examples, SQL executor is an example of a tool. So some people in her network resist using term agent in its context as is already overused. Yeah, that's true. In reinforcement learning, for example. Tools versus plugin. Other than SQL executor, there are many examples of tools. Search, web browser, bash executor, calculator, all these are tools. You can think of plugins as tools contributed to the OpenAI plugin store. As of writing, OpenAI plugins aren't available to public yet. Control flows, sequential, parallel, if for loop. So in the example above, sequential is an example of control flow in which one task is executed after the other. There are other types listed here. So basically different control flows you want LLM to do. So this feels like going back to the programming language again. Control flow with LLM agents. In traditional software engineering, conditions for control flow are exact. With large language model applications, condition might be determined by prompting. For example, if you want your agent to choose between 3 actions, search, SQL executor, and chat, you might explain how it should choose, and then in other words, you can use LLM to decide the condition. So testing an agent. For agents to be reliable, we will need to be able to build and test each task separately before combining them. There are 2 major types of failure mode. So one or more tasks fail, potential cause, control flow is wrong, or one more task produce incorrect results. All tests produce correct results, but the overall solution is incorrect. The fraction of compositional questions that the model answering correctly output all the composition questions for which the model answers the subsequently question correctly. Interesting. So it does look like testing this type of composition of prompting is one of the biggest challenges in this bring this to production as well. Like with software engineering, you can and should unit test each component as well as the control flow. It would be interesting to see what are some of the frameworks that does this type of unit testing. For each component, you can define pairs of input and expected output. Yep, you can, which can be used to validate your application every time. Well, the tricky part is how do you unit test if you have to call a third-party API? I think that's the weird part. That means every time you run unit test, there's also another cost. So that's the other issue. Part 3, promising use cases. The internet has been flooded with cool demos and applications built with LLM, which I suspect a lot of them are rehearsed. Here are some of the most common promising applications I've seen, and I'm sure I've missed some. AI assistant. This is hands down one of the most popular use case. There are AI assistants built for different tasks for different group of users. AI assistants for scheduling, making notes, pair programming, responding to email, helping with parents, making reservation, flight booking, and shopping. But of course, the ultimate goal is an assistant that can help you with everything. This is the holy grail that big companies are working towards for years. That's true. So, next one, chatbots. Chatbots are similar to AI assistant in terms of API. If AI assistant's goal is to fulfill a task given by a user, then chatbot's goal is to be more of a companion. So I guess it's less task-oriented. For example, you can have chatbots that talk like celebrities or game characters or business people or authors. The most interesting company in the consuming chatbot space is probably character.ai. It's a good name. It's a platform where people create and store chatbots. The most popular type of chatbots on the platform is writing or anime and game characters, but you can also talk to a psychologist, a pair programming partner, or a language practice partner. You can talk, act, draw pictures, and play text-based games, or even enable voice for your actor. Wow. I tried a few popular chatbots, none of them seems to be able to hold conversation yet, but it's just the beginning. Yep. Programming and gaming. There's another popular category of LLM applications, as LLM turn out to be incredibly good at writing and debugging code. GitHub Copilot is a pioneer. They're pretty cool demos of using LLM to write code. These, I think it's worth checking it out, but I haven't seen very good ones yet. Otherwise, it will be quite amazing to, a lot of startups that they want to do a landing page, they want to do a quick demo. I think this will be a huge opportunity if this actually can work to a pretty robust degree. So, learning. Whenever ChatGPT was down, OpenAI Discord is flooded with students complaining about not being able to complete your homework. Yeah, I definitely know quite some people using this to do their writing homework. Some responded by banning the use of ChatGPT in school altogether, which shows you how useless those homeworks are, right? Some have much better ideas how to incorporate ChatGPT to help students learn even faster. All edtech companies are going full speed on this. Some use cases including summarizing books, automatically generate quizzes to make students understand a book or a lecture. Not only ChatGPT can generate questions, but it can also evaluate whether students' input are correct. Rate and give feedback on essays, walk through math problems, be a debate partner. Interesting. With the rise of homeschooling, we should expect to see a lot more application of ChatGPT on EdTech. Talk to your data. This is, in my observation, the most popular enterprise application so far. Many startups are building tools to let enterprise users query their internal data and policies in natural language or in the Q&A fashion, obviously for people that are not tech savvy, right? Some focus on verticals such as legal, contract, resume, financial data, or customer support. So that's also because some of those data are unstructured or semi-structured. Given a company's all documentation policies and FAQs, you can build a chatbot that can respond to your company's support requests. Yeah, I think this is an amazing use case. The main way to do this application usually involves 4 different steps. Organize your internal data into database. So it still has to be structured. Give an input into natural language, convert it into query of the internal database, for example, SQL or graph database, and then execute the query and then translate the result back to natural language. So it's amazing. I think executives will really like this when this application become widely adopted. I definitely look forward to see this. This makes for a really cool demo, but I'm not sure how defensible this category is. I've seen startups building applications to the user query on top of database like Google Drive or Notion. It feels like it's a feature that they can implement themselves. That's true. I think this is why a lot of these feature on top of the existing tool that is not expandable are probably bad sort of ideas, but there's nothing wrong, just give it a try and probably will be a lot of learning coming out of it. Can LLMs do data analysis for me? I definitely heard people talk about this use case, having LLM writing SQLs. So the author tried inputting some data into GPT-5 Turbo and seems to be detect some patterns, but it doesn't work very well, which is as expected. Next one, search and recommendation. Search and recommendation has always been the bread and butter of enterprise use cases, of course, for ads, right? It's going through a renaissance with large language model. Search has been mostly keyword based. You need a tent, you search for a tent, but what if you don't know what you need yet? Right, so that's when this conversational based recommendation will be helpful. For example, if you go into a camp in the woods in Oregon in November, you might end up needing, doing something like this. You go to read other people's experience, and then you figure out what you need, and then you search those items. So maybe it's better to just say things you need for camping in Oregon in November, and it will show up the items that you need. So yeah, I think this definitely is an amazing idea. I know several companies are trying this more like a conversational user tell you situational stuff and you give them recommendation rather than they have to know exactly what they need. So this more, in other words, more inspirational based search and recommendation. But what if searching for things you need for camping in Oregon on Amazon actually returns list things that you need for your camp trips? Yeah, that's why it will be so amazing, right? So here's what you can do. Convert user query into a list of product name. For each product name in the list, retrieve relevant items from your catalog. Yep. If this works, I wonder if we'll have LLM SEO techniques to get your product recommended by LLM. Sales, this is the most obvious one. However, several companies in her network are using LLM to synthesize information about companies to see what they need. Okay. SEO is about to get very weird. Many companies today rely on creating a lot of content hoping to rank high on Google. However, given that LLMs are really good at generating content, and I already know a few startups whose services to create unlimited SEO optimized content for any given keyword, search engines will be flooded, which it already is. A lot of newsletters and copywriting materials are written by LLM nowadays. SEO might become even more of a cat and mouse game. Search engine come out with new algorithm to detect AI generated content, and companies get better at bypassing that. Yeah, people might rely less on search and more on brand. Yeah, this is critical. This is wow. People might rely less on search and more on brand, trust only content created by certain people or companies. So it becomes like a more influencer based. And we haven't even touched on SEO for LLMs yet. How to inject your content into LLM's response. So in conclusion, we're still in the early days of LLM. Everything is evolving so fast. She recently read a book proposal on LLMs, and her first thought was most of this will be outdated in a month. API are changing every day. New applications are being discovered. Infrastructure is being aggressively optimized. Cost and latency analysis needs to be done on a weekly basis. New terminology are being introduced. Not all these changes will matter. For example, many prompt engineering papers remind me of early days of deep learning when there were thousands of papers describing different ways to initialize weights. Okay. Like randomly or use word2vec. I imagine that trick to tweak your prompt, like, writing questions that cute wouldn't matter in the long run. Given that large language models seem to be pretty good at writing prompts for themselves, who knows that if we'll need human to do prompt tuning in the future. However, given so much is happening, it's hard to know which will matter and which won't. So that's it for this article. It's actually a pretty fun read. She summarized it pretty well with different sections, such as the challenges, the core feature, which is task composability, to make it function more like a programming language, and then some of the use cases. I love it. and I hope you guys enjoyed this article as much as I do. So thanks for watching, and if you like this type of content, please don't forget to subscribe and like. Thank you.